on YouTube? Welcome back. This is part 3 of finding entities on any game. No, if anyone's paying attention to the time, no, it did not take me like 2 hours to find my why. I just had to get some stuff done. So now that that's done, in this video we're gonna actually be doing a little bit of reverse engineering, and the first thing that we're going to do is we're going to try to create I'm going to teach you guys how to create a pointer, um, a multi-level pointer without the use of the pointer scanner. And this is useful in certain instances where you absolutely um, need to be able to let's see, give me a second, let me think. I'm kind of having a brain fart right now. Um, this is useful. Why would you use this over a pointer scan? It's basically just to get a better understanding of what's going on, because a little bit more is required, because you have to, look at classes individually, and you can get information from those classes, I should say, and we're going to be discussing that in this video. And also, tracing this way too is pretty helpful whenever you're trying to find other values in the game. Say like, you're trying to find the player entities. Let's say you're trying to find like the y-axis for other players. This method is useful as well. You could obviously manually, have a friend join the game, maybe have them jump up and down, and you could scan, their position in the game, or you could scan their health. You could scan a lot of different things, really, but some games and values are encrypted, so you might want to use this method for that too. So yeah, those are all the instances that I think you could use this. And we're going to be using the information that we get from using this method to basically get to the end goal, which is being able to go through the entity list and seeing every player in the game. Because once you know the player's position in game, you're able to get a lot more information, and you can use that information to make cheats like ESP, aimbot, and stuff like that. So you could calculate the player distance and all that good stuff. So it's a pretty useful tutorial. So let's get into it, guys. So as you can see, I have my Y here. I'm just gonna rename it to Y-axis. All right. Just to show you guys that it is my Y real quick. I'll change the value. And, it jumps a few studs in the air or whatever Roblox uses to measure um, height or whatever. So what we're gonna do now is you want to go ahead and click find out what axis this address, okay? And you can see a bunch of results here. All right. Mm. Mm -mm 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 -mm. All right. So like I was saying, we did find out what axis on the y-axis. Um, Now you got all these results that come out. You're probably looking at me like, what the hell is all of this? I don't know any of that stuff. Um, to be honest, it's really simple, and I'm gonna explain it in just a little bit. So, I do recommend you learn assembly, some basics assembly language. But matter of fact, you won't even need it. You won't even need it for this video, because everything that we go over in this video, I'm going to explain what that assembly code does. So the first thing that we want to talk about, in the past couple of videos, I was talking to you guys about inheritance, okay? I was talking to you guys about how big brain inherit from little brain, and ND inherit from big brain, and now entity can walk, jump, swim, it could count, it could say ABCs, it could save memory, it could see, it could hear, and it could feel, okay? Now you see all these functions here, guys? You see all these functions? Um, Whenever you make a class in C++, which is the same code um, or part of what was used to create Roblox. Whenever you create classes, um, your compiler, Visual C++ or GCC, GNU compiler, whatever you use, um, what it's going to do is, well, I can't say for every compiler because every compiler is different, but I know for sure Microsoft compiler does this. So um, whenever a class is created, what the compiler basically does, you see all these functions, it takes them and it puts them in this thing called a virtual function table or a virtual table. Now, all a virtual table is just a way of accessing all these different functions here. So you see how I created an entity for Prince of Oblivion, my character. Well, at this location, the first location of that entity class, of that object that I created, you're going to see the virtual function table, okay? And in that virtual function table, you're going to have the functions for walking, jumping, and swimming. So that's basically how that works, all right? So whenever I'm trying to find a multi-level pointer, I don't try to trace or do a pointer scan on anything that's not a class. And based on common conventions, like how I told you guys, when you create classes, a class starts off with a virtual function table, and then it has all the class members. So you see, um, with the Prince entity here, it starts off with a virtual function table, and then it has all the other values. It has the x-axis, it has the y-axis, and it has the z-axis, okay? And don't worry about these numbers here on the side. They're basically just how the information is indexed in memory. Um, I could do like 1, 2, 3, 4, but I'm going off of how pointers are called these things called D words, and so they're 4 bytes in size. So every time I go up, I have to increase by 4. So that's why you see I'm counting by 4. And this C, if you watch my previous tutorials, you know that the C is in hexadecimal. It just stands for 12. So um, yeah, so let's get back to it, guys. Finding classes, finding entity classes. All right, so we have all these results. I'm already gonna knock out a bunch of these results by showing you guys how we could tell whether or not they're a class. So you see all of these functions, what they have in common. Whenever you do a find out what access in cheat engine, it always assembly code. Let's go ahead and let's copy this instruction, for example. This is the current instruction, EAX plus 20, and then it says move ups XMMO EAX plus 20. Okay, let's copy that and try to dissect it real quick. Okay, so let's open a new notepad here. All right, I'm gonna go ahead and paste that and get rid of the bytes and the address because we're only worried about the code right now. Okay, so here we are. So in assembly language, there's a common instruction called move. Um, it, basically all the move does is copies data from one location to another location. Okay. It doesn't necessarily move it because you the old let's say I had two variables. Let's say I had a b and I had let's say I had a local variable named a and its value is 3. Let's say I had another local variable named b and its value is 5. You want to keep in mind in assembly, um, based on this, in this scenario, the syntax, which is the same syntax that's used for cheat engine and a bunch, IDA and a bunch of different. This is like I can't remember the exact syntax, but there's 2 different syntax for it. I can't remember the name right now, but in assembly, um, based on the syntax that you're using, and in this case, it reads from or I guess you can say it reads from right to left. Okay, so let me go ahead and get rid of that. Reads from right to left. Okay, so what that basically means is um, anything that's on the right is going to go into the left. So you could think of an EX plus 20. You could think of this as the source, and XMMO. Matter of fact, let me not use that. Let me go ahead and rewrite the instructions so it's simpler. So let's do something like this. Let's instead of A and B, I'm going to be using the registers um, in assembly, which they're basically just like variables. So nothing too different there. It's just for demonstration purposes. So let's say I did an instruction like this, right? Like I said to you guys, it reads from right to left. And the move instruction, what it does, it copies data from one location to another location, okay? So you see something like this, move you see it says move EAX, comma EBX. Now, generally speaking, anyone that reads from left to right, you're going to think this says move EAX into EBX, but it's actually the opposite way around, because like I said, we're reading from right to left, okay? So you start off with the instruction first. So this is the move instruction, and what it's basically going to do is it's going to take this EBX value, which has 5, and it's going to copy it and put it into EAX. And the reason why I say copy is because EBX still has the same value. It doesn't just take the 5 out and put it in EAX. After we do this, that's why the instruction could be a little bit misleading. But after we do this instruction here, EBX is still going to be 5. So let's say that executes. Let's say that we run that. And after we run that, the output is going to look something like this. EAX is going to equal to 5, okay? And EBX is going to still equal to 5, okay? And you could do stuff like add EAX, comma EBX. Same process that I was talking about earlier. Remember we're reading from right to left. So you take the 5 in EBX and you add it to EAX, okay? So the output would look something like this. Output. All right, so EBX is gonna equal, or I should be saying, EAX is gonna equal EAX plus EBX. So we're taking EBX and we're adding it to EAX, and so the output of EAX is gonna be 10. So I hope that makes sense. If it doesn't, don't worry about it. You could find other tutorials, or you could follow my series on assembly later on. So now let's get back to this instruction here. Now we see something a little bit familiar. This says move, but what is this right here? What is this ups right here? Now, generally speaking, there's multiple forms of move in assembly language, and you use different moves for depending on the type of data that you're dealing with. Same with registers. We could basically compare registers to variables like EAX, EBX. I was talking about. In the same sense, that depends on the type of register that you use, depend on the type of data that you're using. So in our case, our y-axis is a float, right? So whenever you're using float data type in assembly, whenever it's dealing with a float data type, it uses completely different instructions than what it would use for just a regular data type that was like 4 byte or decimal or something like that, okay? So, and that's why you see this ups here, or UPS. That basically means that we're dealing with a float data type, okay? And so XMMO is basically the same scenario. In assembly, you have different registers, or you could kind of view them as variables for the CPU. You got AX, EBX, ECX, and so on and so forth, okay? Now, when you're dealing with floating points, you have things called XMM0, XMM1, XMM2, and so on and so forth, okay? All right, and then this here in the brackets normally brackets basically represents pointers, okay? So, um, so far, let's go ahead and rewrite this instruction. If this wasn't a floating point, we just want to make it easier. It would probably look something like this if we were just dealing with a regular decimal and not dealing with a floating point. So now it looks a lot easier now. So let's dissect this EAX plus 20 here, okay? EAX plus 20. This is a pointer, and basically all this does is going to see this instruction here. It says EAX equals this value. Okay, let's copy that. Go back to Notepad. All right, so in place of EAX, we're going to go ahead and take that address that we just copied because that's what EAX equals. Okay, and we're going to go ahead and add 20 to it because that's what the instruction is saying. It's saying EAX plus 20. Okay, so now let's get Windows Calculator real quick and go ahead and add those values together, so I can show you guys for demonstration. Let's get it up and running real quick. Alright, give that a second to load. Okay, boom, here we go. So we're gonna go ahead and copy that address again, and we're already on our programming calculator. The address is in hexadecimal because everything in machine code is represented in hexadecimal. And we're gonna just go ahead and paste that address, and then we're gonna add 20 to it. Okay. Now when we add 20 to it, we see 3137 DEE8. Okay. Let's go ahead and copy that value. And let's go ahead and rewrite our pointer. So this is what our pointer looks like now. And now, let me show you something. Okay. Now I see what it is. Okay. So, what this is basically doing, it's indexing a, this is actually pointing to our coordinates. Now, in the case of this instruction here, the move ups, normally a typical move instruction, it's going to move up to 4 bytes of data. This, which can also be translated to a D word. There's also other instructions that they can move more, a larger amount of data than normal. So a D word would be consistent of 4 bytes, and then a let's see, what is it called? A Q word would be consistent of 8 bytes. So a Q word would go all the way up to here. Okay. All right. So basically, what's happening here? Give me a second. Alright guys, welcome back. So I had to stop the video so that I knew what I was talking about, because it was actually my first time seeing an instruction like that, that looks like this. Like I've seen like move SS and stuff like that, but I've never seen one that says like move ups. So I went ahead and decided to do a quick Google search. This website is really, really useful. And so I basically looked up the move ups instruction. You can see that the acronym stands for move unaligned, packed, single precision, floating point values. So like I was telling you, assembly uses, if we're dealing with a floating point, like our y-axis here, which is 5, we're going to be using floating point instruction, which this is a floating point instruction. Now this is a very type of special floating point instruction. It says here that whenever the XMM register is used, multiple instructions that I've been familiar with in the past, they normally typically only take a D word. Like I said, like a typical move instruction would move a D word. So it would move up to 4 bytes into some other location. It would move it into another register or what have you, okay? And then a Q word, an instruction that could move Q words, it would be able to move up to 8 bytes, okay? 1, 2, 3, 4, 5, 6, 7, 8. Okay, just wanted to make sure. So that's a Q word. It moves up to 8 bytes, all right? And what am I looking at right now? Let me make sure that we're on. Okay. All right. I just wanted to make sure that I was looking at the address that we added earlier. Okay. So, anyways, a D word, a D word is 4 bytes. This also translates to 32 bits, and then a Q word is 8 bytes, and that translates to 64 bits. Now, it says this instruction here, this move ups, whenever XMM is used, it could take up to 128 bits of information, or in other words, 16 bytes. Okay, so right now we got 8 bytes highlighted. Um, so that means, remember when we add, oh, Jesus, what am I doing here? Anyways, I'm opening all kind of craziness, man. Just give me a second, YouTube. Bear with me. Having some technical difficulties. Okay. Anyways, here we go. So we got this address here. Whenever we added it together, we found that EAX was this here, and then we added it together. Now we got this address here. Okay. So now we're looking at that in memory. This is that address here in memory, and um, like I said, that move ups instruction, it can move up to 128 bits. This is also called a octaword. Okay, 128 bits or 16 bytes. Okay, and so that means that from here, that's 4, right? Now we got 8. Now we got 12, and boom. Now we got 16 bytes total. You count all that up, that adds up to 16 bytes total. Now, whenever you see how I put my remember when I made my entity for Prince of Oblivion, and I put my X, Y, and Z, they're normally always in the same place. So we're at 3EE8 right now. So you could imagine this is probably like that. It might not be in any you'd have to figure it out yourself by experimenting with the values, but let's see. It says here um, that my y-axis is at 3137 DEF0. Okay, so this says 3137 DEE8. Okay, so let's go ahead and change the format to 4-byte hex so that it's easier for us to read. All right, so DE8. This is what we got when we added EAX. Okay, and now we see EC here. Let's see, and we're looking for F0, okay? So F0, this must mean that this is our floating point value, and this is represented in hexadecimal, okay? And that specific move ups instruction, it could access, it takes basically all of this stuff and shove it into XMMO. So that's basically what it's doing. And within um, these, within what I've selected here, um, this is generally, or few of these, I'm not sure which one exactly, I'll have to figure it out, but they're going to represent your X, Y, and Z coordinates. I already know that this one is Y, because I found this one earlier, and it says here that, F0, 3137 DEE, or DEF0 is my Y-axis, okay? So now that's my Y-axis, and I could go ahead and change the display type to float, and boom. You see 5 here, and boom, you see 5 there. So that's basically why we see in this menu, why we see it came up when we try to do a find out what axis, and on our y-axis we see this instruction comes up. Okay, so the next thing that we need to do, now that we figured that out, what the instruction means and dissected and everything and all that good stuff, now we need to find out. Remember I was telling you about oh my god, bro, if I open code blocks one more time. Come on, come on, come on. Okay, so let me hop on real quick before I lost my train of thought. Okay, guys. So, um, you know who was talking about inheritance? Let's get back to inheritance again. Whenever you inherit something, you're gonna have what's called a base class. So you could say entity is the base class, and then it inherits public big brain. Okay, and then big brain is the base class um, to little brain. Okay, and that would keep on going, so on and so forth, depending on the amount of classes that you have. So you could kind of in brackets here, um, whenever you create classes, again, methods are automatically put in a thing called a virtual function table, okay? And then all of the members of the class are accessed, um, you know, by going through that object, okay? So I'm gonna go ahead and I'm gonna copy EAX real quick and try to show you an example. Okay, so let's go ahead and change this back to 4-byte hex. And let's go ahead and do dissect data structures real quick. Okay, we're gonna go ahead and copy this. This is the base. Kind of think of it as the base of the class. So imagine to test if EAX was a class, I would get the base. The base is anything um, like, say for instance, I keep having to go back to it because it's a really good reference. Okay, so you see EAX is 3137DEC8. Let's imagine for a second that Prince of Oblivion, my character, let's imagine that its address was located here at 0, okay? And so the first element, we're going to have the virtual function table, and that's going to be able to tell us all the functions, and then we're going to have all the members that we could access. So um, if I were to say, let's say that Prince of Oblivion was located at that address, okay? Let's say that this is where Prince of Oblivion was located, okay? So if I wanted to access, let's say, the x-axis, then I would simply do EAX plus 4, because that's where x is located. Likewise, if I wanted to access the z, then I would do EAX plus c, because that's the location. And remember, that c is in hexadecimal, so that's basically saying EAX plus 12. And we're adding by 4 because this is a D word. Pointers and a lot of data, they're represented, you know, in D word. That's why you have 32-bit applications, because that's the size, that's the max size. And then in 64-bit, then it goes up to Q word and so on and so forth. Um, so yeah, that's basically how that works. So um, you could think of this C8 here. This is the base. This is like the structured Prince of Oblivion. It's like a pointer to it. You could think of it like that, okay? And if I were to do EX plus 0, then that's the virtual function table. This is the um, X, and then, of course, plus C is the Z, okay? Let's go on over here and do a quick dissect data structure so that we could try to see and see if this is a class, see whether or not this is a class, okay? We're gonna see if it follows those standards. All right, I'm gonna go ahead and delete all my old structures and define a new structure. We're gonna name this structure, let's just name it local player, okay? Yes, and click yes. Alrighty, so we already noticed right off the bat, if this was a class, we're seeing that at 0, it's saying that it's a float. But when we look at our demonstration, um, based on the standards, we see that in the class, the virtual function table is always supposed to come first. And the virtual function table is not 0.7337. So right off the bat, I know that this right here is not a class. It's probably a pointer to something. And, I shouldn't be using that um, if I'm trying to do a, um, manual pointer, multi-level pointer, because that's not gonna it's really not gonna lead you to much. You can't use this as an instance because it's not the base. You can't use it to reference other members because you could think of it as you're just at some random location in memory, because let's say that hmm, nah, never mind. I don't want to confuse it. I'm gonna leave it at where I left it. Okay. um so yeah, we know that that's not it, so we're gonna go ahead and delete that structure, and we're going to look at some other addresses. And I'm going to stop the video right here, and we're going to talk about it in the next one some more. Uh,